Yes, distribution function is a CDF. The lowercase f, this one is a PMF. And they're asking you to find the uppercase f. So for the PMF, we can draw a PMF table based on what they gave us. It is not necessary to draw this table, but it's just my habit of working with it. So I will first write out all possible value that x can take. It can be 1, 2, 3, 4, 5, and 6. And then probability that x is equal to a specific value is given by this function. If x is 1, then the probability is 1/21. If x is 2, then probability is 2/21. And we follow the same approach to fill in the rest of the table. Now we want to calculate f of t, the distribution function. So distribution function, you have to clarify it for all real number. We see that x cannot take on any value before 1, right? 1 is the minimum, which means for all value, for all input that is less than 1, then the probability, this one is probability x is less than or equal to t, right? If t is less than 1, let's say like 0.5, we can see that probability that x less than or equal to 0.5 is just 0, because x started 1. Before 1 is impossible. So it is 0 here. And next, we will calculate if t is between 1 and 2. And notice that here, I use greater than or equal to 1 and less than 2. Are you saying something? I don't know if it's just me, but I don't hear anything. Oops. Can you hear me? I'm pretty sure that my mic is working. Okay. So here, t is at least 1, but it is strictly less than 2. We will see why is that. So for any number between 1 and 2, let's say probability that x is less than or equal to 1.5. It is the same as probability x is less than or equal to 1, because x is discrete. If you look at all possible value of x, which one is less than or equal to 1.5? This one, right? And it is also less than or equal to 1. If you do a 1.7, it will still be the same probability, or 1.999, it will still be the same probability. And it is just 1/21. Next, we move on to t between 2 and 3. We will have that probability that x is less than or equal to t. Let's just pick some number between 2 and 3, like 2.3. It is the same as probability x less than or equal to 2, right? Because the values of x, it cannot be anything between 2 and 2.3. So these two probability are the same. And what is probability x less than or equal to 2? We have to see what are possible value of x that is less than or equal to 2. It is just 1 and 2. So we have probability of x equal to 1 plus probability of x equal to 2. And we would have 3 over 21. Next one is between 3 and 4. Between 3 and 4 would just be probability x equal to 1 plus probability x equal to 2 plus probability x equal to 3. So we would have 6 over 21. Between 4 and 5, we plus all these probabilities together, and we would have 10 over 21. Next one is between 5 and 6. We'll just plus all these probabilities together, and we have 15 over 21. And then if t is at least 6, you will add all these probability together, and it should give you 1. So these are the distribution function that you need to find. Any question about this one? If there is no question, I will let you move on question 2. Before you do that, I just want to say for the kind of question that asks you to find a constant such that some function is a valid PMF, you will need to use the fact that, yes. Let me know when you finish. Yeah. So for this one, we have to use the fact that summation of the probability is equal to 1. And then you would also need some formula. I created this one for the winter 107, but we can use it here. For this course, these are the 3 formulas from calculus course that you should know. Finite geometric series, infinite geometric series, and Taylor series expansion of e to the power of x. You will see that one of them will help you with this question here. So I will give you a few seconds to screenshot it, and then I will go back to the question. I will take it up in maybe 4 minutes. If you have any question, feel free to put in the chat. Okay, so if we use this property and we try to plug it in, this one means that we will go through every possible value in the range of x. The range of x starting from 0 and it ends at infinity. So we will start at x equal to 0 and ends at infinity. And then probability mass function of it is given by this formula. So I just put it down. C is a constant, so I pull it outside the summation. This one here, it should look like this. So we have summation from 0 to infinity, and then some number to the power of n divided by n factorial. Here, x act as n in that formula. And x here is 2021. So the whole summation is equal to e to the power of 2021. And c would be 1 divided by that. Any question about what I just did? This formula won't be provided on the exam, right? Yes, it will not be provided in the final exam. You need to know it. Just keep in mind it involves the index starting from 0. If it is 1, it is not equal to e to the power of 2021. If there is no other question, let me see. We can work on question 4, and if we have time, we will go over 3. Okay, so if we use the formula, variance of some random variable like 3x plus 5, it would just be equal to 3 squared multiplied with variance of x, which is 9 times variance of x. So now, in order to calculate this quantity, we will want to find what is the variance of x. Variance of x is given by expected value of x squared minus expected value of x and then square that number. From the first information, we can find expected value of x from here because the left-hand side is equal to 3 times expected value of x minus 2. So expected value of x would be 9/3, which is 3. From the second information here, I will expand inside out. What is x plus 7 squared? It is x squared plus 14x plus 49. Then the left-hand side equal to expected value of x squared plus 14 times expected value of x plus 49 and is equal to 101. Expected value of x is 3. So 14 times 3 would be 54. And then plus 49 equal 101. The value here, let me see. So we have 3. Did I make calculation mistake somewhere? 3 times expected value of x minus 2 equal to 7. So that is 3. That is fine. And then this one we got x squared. And then plus 14x plus 49. 14 times 3. Oh, it's 42. My bad. So here, expected value of x is 3. So we would have 42 here. And then the summation here would be 91. Then this would give me expected value of x squared is 10. I take 101 minus 91. So I have 10. Now I have this quantity. I also have expected value of x. So I can calculate variance of x. It is 1. And then I will plug variance of x into here so that I can calculate variance of 3x plus 5. And this one would be 9 times 1, which is 9. So this is our final answer. Any question about that? If there's no question, let me see. We only have 5 minutes left. I will go over question 3. So we have a gambler plays $10 to enter a game, and he throws 2 dice. If he got exactly 1/6, he received $15. If he got 2/6, then he received $30. And if he does not get any 6, he receives nothing. We want to find his expected profit from the game, which means we want to find expected value of X, where X denote profit that he got from the game. Okay, if we think about it, if he receives $15, then what is the profit that he got? He has to pay $10 to enter the game, right? Which means his profit is 5. Similarly here, if he received $30, then his profit is 20. And if he received nothing, it means his profit is -10. He actually lost. We will want to find the probability that he got each of the profit here. He got profit -10 when he does not get any 6. Think about these two as the outcomes when he throws 2 dice. He got no 6 mean that each of the position, he just got some number from 1 to 5. Then the probability that this happen is probability that this spot is some number from 1 to 5, and this spot is some number from 1 to 5. This will give me 5/6 times 5/6, which is 5/6 squared. Probability that he received $5 profit is when he got exactly 1/6, which means he can get 6 on the first dice or 6 on the second dice. Once you figure out what is the position for 6, you will want to put 6 in. Probability of getting 6 is 1/6. And then the remaining position would be any number from 1 to 5. He got profit of $20 when he got 2 6, which is just 1/6 times 1/6. So these are the probability mass function for the random variable that denote the profit that he got from the game. We want to find expected value of X. What I suggest students do normally is create a row below the probability mass function. And what do you calculate for this row? You calculate the value that X can take, multiply with the probability that X takes on that value. So here you multiply this one with this. For this one, you just multiply this with this. For the last one, you multiply this with this. And then the expected value would be the summation of this row. You take everything, 3 number here, adding together, and the sum is expected value of X, which means the expected profit that he got from the game. Any question about this one? Or like the tutorial in general? If there is no question, that is the end of our tutorial. I will still see you on Monday. Do you know when the final is? I believe it is next week, I think. You can check on the UTM website. I think it is on Thursday. I'm not sure next week or next week. You should check the date again on the website. And yes, it is cumulative. But I'm pretty sure that he will put more emphasis on the end of the course, which means like random variable and then some discrete distribution. But it's not really something new. It's all that we can reason using combinatorics that we learned in the beginning.